Very good morning, students. Today we can continue our topic of physics, that is system of particles and rotational motion. Okay. Yesterday we have learned about the two theorems, that is principle of parallel axis theorem and principle of perpendicular axis theorem. In first theorem you have learned IO is equal to IC plus MH square, and the second theorem you have learned IZ is equal to IC plus IY. After that, getting the two theorems, we have started to calculating the moment of inertia of the different bodies, and the first body that we have considered as a thin uniform rod. And I think so the first point you have also learned moment of inertia of thin uniform rod about an axis passing through its center. Okay, so if I will consider this is the rod having the length is supposed to be L, M is the mass of the rod, and if I want to find out the moment of inertia about its transverse axis or that axis which is passing through center but perpendicular to its length, that answer is ml square by 12. So that you have learned. If I want to find out the radius of gyration, so that formula becomes kc is equal to under root of kc by m, or ml square by 12 1 upon m. M get cancelled, so under root of L square will be L and square root of 12 or L upon 2 into root 3. So that is the last point which we have been learned. Now we can continue to the next point, the moment of inertia of thin uniform rod about an axis passing through its one edge. Which one we want to find out? Moment of inertia of a rod about its one end. Now here in that case we know the moment of inertia which about its axis which is passing through its center, and I want to find out moment of inertia about this axis. Given axis is IO. I know if this total length is L, so naturally this distance between IC and IO means that two parallel axes is supposed to be L by 2. And if I want to find out that moment of inertia, so how I can calculate? So here I have the one principle, according to principle of, that means a parallel axis theorem, IO is equal to IC plus MH square. So I have the IC which I have already calculated, so that is equal to ML square by 12 plus M into, and H will be L by 2 square. Okay, and that is equal to moment of inertia about its one end. And so therefore your answer will be ML square by 12 plus ML square by 4. And if I will calculate this answer, so your IO will be is equal to ml square. If LCM is 12, so 12 on the 12 4 3 I will 3 plus 1 4 means that will be 4 ml square. 4 on the 4 4 3 means 1 by 3 times ml square. Okay. Or we can also say that this formula is ml square by 3. Okay, so that is the moment of inertia of a rod about its one end. What is that answer? Ml square by 3. Okay, once you got that answer, then we want to find out, sir, what is the KO for that. So that answer will be IO upon that your M. So that is equal to ml square by 3 upon M. Okay, M will get cancelled, and so therefore L by root 3. So this is the your second formula. If I want to find out the third formula, moment of inertia of thin uniform rod about an axis. Okay, about an axis, but that axis is passing through where? The midway between its one end, midway between its one end and center of the rod, Okay, so here we want to find out, means exactly, suppose this is the rod. Okay, so this is the center, this is the one end, but now I don't want to find out its one end, at the midway between the one end and this your that center of mass. So therefore IC we know, and I want to find out IO here like this. Okay, so this distance will be now L by 4. So again I will use the principle of parallel axis theorem. IO is equal to IC plus MH square. Okay, and here what is IC again? ML square by 12 plus M into L square by 4 square is 16. So therefore ml square by 12 plus ml square by 16, LCM is 48. So 12 4s and 16 3s 7 ml square by 48. So therefore that will be IO. naturally KO will be here in that case under root of 7 by 48 into L. Okay, or if you want to find out square root of 7, 4 3s are 16 into 3, so 4 into root 3, so that will be L. So that is also because 16 3s are 48. Okay, so that will be the your radius of gyration for that your thin uniform rod. So these are the three different cases that which we want to calculate. Now I'll go for the second, that means body, which we can consider as a ring. Okay, so I'll rub that all these things and we can go for second next body, that is the your thin ring, and we want to find out the moment of inertia about the thin ring. Okay, which is the about an axis which is passing through center perpendicular to its plane. Okay, so that we can calculate. So moment of inertia of a ring. Okay, ring, and we want to find out about an axis passing through its center. Okay, passing through its center and perpendicular to its plane. So suppose if I'll consider this is the ring. Okay, so here this is the center. So I want to find out that moment of inertia. So moment of inertia of thin ring about an axis, okay, which is passing through the center perpendicular to its length is, now you can see it. So this is the ring and I want to find out about this axis. So that answer will be mr square. What is that answer? Mr square. So therefore, if this is the IC, moment of inertia, so then what is the radius of gyration? Radius of gyration here in that case will be Kc is equal to under root of IC by m, and that is equal to mr square by m will get cancelled under root of r. So therefore, Kc is equal to under root of r. Okay, so that will be the under root of r means square root of r square will be r only. Okay, so that will be the your right answer. Next point, if you want to find out about its any diameter, okay, moment of inertia of a ring about any diameter. Now sir, for that case, so what I have to use? So I will use here the principle of perpendicular axis theorem. So this is Iz, this is Ix, this is Iy. So this is also Id, this is also Id, because you see here if these are the, that is diameter of the ring, then according to principle of perpendicular axis theorem that you have already calculated, what is that formula? Iz is equal to Ix plus Iy. But here Ix is also Id, Iy is also Id. So therefore Iz is equal to Id plus Id. Okay, so that is equal to 2 times Id. Okay, 2 times Id, that is equal to Iz. Or moment of inertia about its any diameter is equal to Iz by 2. And what is Iz now? That is Ic, which is we have calculated as a mr square. So therefore mr square by 2. So that will be Id. Once you got that moment of inertia about its diameter, then its about its diameter, radius of gyration can be mm will get cancelled, r by root 2. What will be the answer? That will be again r by root 2. So that we can directly consider here like this. Next point, I want to find out the moment of inertia about that of the ring about an axis which is passing through a tangent to in its own plane. Moment of inertia of a ring about tangent to its plane, own plane. Okay, so that means parallel to plane. Okay, in its own plane means that is considered to be a parallel. Okay, parallel to its plane. So then in that case, suppose this is the ring. Okay, so you have calculated the diameter. So this is the parallel to its plane. Okay, you can consider this is the ring and that axis is parallel to its plane. Now, so this distance will be r. Okay, so that diameter IC you know. I want to find out IO. Again here I will use the formula for parallel axis theorem. What is that formula? You know, O is equal to IC plus MH square. IO is equal to IC plus MH square. So therefore that IO is equal to, you have calculated IC, that is the MR square by 2 about its diameter, plus that is the M into R square, and that answer will be 3 by 2 into mr square. So that is the moment of inertia of ring tangent to it in own plane, that is 3 by 2 mr square. So therefore that KO is equal to, mm will get cancelled, under root of 3 by 2 into r square, r will be out, so 3 by 2 into r. So therefore KO is equal to under root of 3 by 2 into r. Okay, so that will be the tangent in its own plane. Next point, moment of inertia of a ring about tangent perpendicular to its plane. Okay, tangent perpendicular to its plane. Sir, how will be that nature of that moment of inertia? So here suppose this is the ring. Okay, so here in that case, if I will take, this is the tangent, okay, perpendicular to its plane. So this is the ring and this will be the tangent. Okay, so now here in that case, if I want to find out this thing, so here this axis I know, moment of inertia of a ring which is passing through its center perpendicular to its plane, that I know. I want to find out this moment of inertia, and that distance is supposed to be r. Okay, so that distance is h is here radius. Okay, so again I will use here parallel axis theorem. IO is equal to IC plus MH square. So can you tell me what will be the IC now here? IC will be MR square plus that M into that distance between the two axes will be r. So therefore mr square plus mr square, that is equal to 2 times mr square. So that will be moment of inertia about that means ring tangent perpendicular to its plane. So sir, what will be the radius of gyration? If I want to find out KO, so then finding out KO, I have to use here the formula under root of IO upon M. So that is equal to 2mr square upon M. Mm will get cancelled, and so therefore under root of 2 into r. So that will be moment of inertia, that means the radius of gyration of, that means the axis tangent to in it, that means tangent perpendicular to its plane. Okay, means here that is how we are finding out the moment of inertias of that ring, of that body about the different points. Okay, now we can proceed to the next point, that is moment of inertia of a disc. Okay, and for calculating the disc, you have again calculate the 4 points moment of inertia of a disc passing through its center, moment of inertia of a disc that is about its any diameter, moment of inertia tangent parallel to its plane, moment of inertia tangent perpendicular to its plane. But the things we can calculate in the next period. Okay, today we'll stop here.